Hi ladies, it's Mr. O'Sullivan. Today we're going to be learning about how to simplify radicals, and when I talk about simplifying, we're going to be doing some level 1 and level 2 questions. So the notes look a little different compared to how when we did them in the spring when we transitioned to remote learning. What we're going to be doing today is we're going to be focusing on just looking at the radical by itself, and then we're going to focus on adding and subtracting them. So I believe in the spring we learned how to add and subtract them, but we didn't learn how to multiply and divide them. Tomorrow, what we'll be doing is we'll be learning how to multiply and divide them. So today's lesson is 1-8a, so we're going to be doing 1-8b tomorrow. The learning target for today is I can apply radical properties to break apart radicals and adding and subtracting expressions containing radicals. So last year we learned that to simplify a radical, we would use this method called prime factorization, and we would use this trick that actually Miss Daniel told me about called double on the inside, single on the outside. So as we move along in this course, radicals are going to be playing a very, very special role in properties of right triangles and similarity, which we're going to be covering in the second half of this course, so in 2021. So the level 1 questions are going to be pretty straightforward in terms of we're simply just going to be using prime factorization to simplify them. So simplify each of the following radicals, make sure that you use prime factorization. So the first radical we want to simplify is 75. So we need to ask ourselves, what are two numbers that multiply to 75? Remember, we don't want to do 1 and 75. We want to do another combo. Well, I know that 5 goes into 75, so I'm going to break it apart into 5 and something else. I know that 5 times 15 goes into 75. I know that 5 is a prime number, so I'm going to circle it. I now have to ask myself, how can I break apart a 15? I can break apart a 15 into 3 and 5, and I circle my 3 and my 5 because I can't break them apart any further. So now the rule that we went over in the spring says that we have to put all of our circled numbers under our radical. So that's exactly what I'm going to do right now. I'm going to redraw my radical, and I'm going to put 2 5s and a 3. So 5 times 5 times 3. And the rule says double on the inside, single on the outside. So what we have to ask ourselves is, do we have any doubles? We do. We have a double 5. So we simply just put our 5 on the outside, and we get 5 radical 3 as our final answer. Now let's go on to our next example of radical 80, or the square root of 80. I have to ask myself two numbers that multiply to 80. Can you think of some? I'm going to use 8 and 10. I now have to ask myself, how can I break apart those numbers any further? Well, to break apart an 8, I do 2 and 4. And I can't break apart the 2 anymore, so I circle it. And I can break apart the 4 to be 2 and 2. And then I circle it. I only circle the numbers that are prime. I now need to ask myself how to break apart a 10, and I can do 2 times 5. So I have a lot of prime numbers circled. Our next step is to put all those prime numbers under our radical. What I like to do is I like to put 2's with 2's and then other numbers with themselves. So I'm going to do the square root of 2 times 2 times 2 times 2 times 5. And again, we have to ask ourselves, double on the inside, single on the outside. So I have a double 2. I put that on the outside and it just becomes a 2. I have another double 2. I put that on the outside. So I really have 2 times 2. And then I have a 5 hanging out by itself. So I ask myself what 2 times 2 is, and 2 times 2 is 4. And then I simply have the square root of 5. And that's your final answer. Try do the square root of 50 by yourself. So when I break apart my square root of 50, I break it off into 2 and 25, and then I can do my 25 break apart into 5 and 5. I circle my primes, and then I'm left with the square root of 2 times 5 times 5. My double 5 becomes a single on the outside, so I have 5 radical 2, and that's my final answer. Let's go on to this next component where we actually have to add and subtract our radicals. So to add or subtract our radicals, we have to follow one key piece of information. To add or subtract radicals, we need to follow combine like radicals. So similar to how we do x's with x's, numbers with numbers, we do the exact same thing with radicals. So what we want to do is we want to combine our like radicals. Note, you're going to need to simplify first, 99.9% of the time. So our first example, we have negative 2 radical 3 plus 3 radical 27. Well, first, I really can't break apart a radical 3 anymore because it's radical 3, so 3 is already prime. So I'm basically just going to want to simplify my 3 radical 27. So I go to the side of my paper, and I write down 3 radical 27. And now I have to ask myself, how do I break apart my 27? Well, to break apart 27, you have 3 and 9. My 3 is prime, so I circle it. So I now need to break apart my 9, and I can break apart my 9 into 3 and 3. So I circle my primes. I circle my 3's. So now what I'm going to do is I'm going to do my 3 radical 27, but I want to make sure that I put all my primes under the radical. So I have 3 radical 3 times 3 times 3. I now circle my double on the inside, single on the outside. And now I have to say to myself, well, I just brought a 3 on the outside. So I have to do 3 times 3. 3 times 3 is 9. So I have 9 radical 3. So 3 radical 27 is equivalent to 9 radical 3. What we're going to do is what I like to do is I like to basically call this my scratch work or my side work. So I typically put a cloud around it to basically say oh, this isn't the problem. This is just helping me do the problem. So I put a little cloud around it. And I basically now rewrite my expression. So I have negative 2 radical 3 plus, we said 3 radical 27 was basically 9 radical 3. I don't combine the inside radicals. That will always be a radical 3. So I have to ask myself, what's negative 2 plus 9? 7. So I get 7 radical 3 as my final answers. Let's go on to this next example. What I'm going to ask you to do is actually simplify your 8 radical 45 and your 3 radical 80 by yourself. When you simplified 8 radical 45, you could break apart your 45 into 9 and 5. Your 5 is prime, so you circle it. And then I can break apart my 9 into 3 and 3. After I rewrite all my primes into my radical, I have 8 radical 3 times 3 times 5. My 3's are a double, so I pull it on the outside, and I do 8 times 3, which is 24. So I have 24 radical 5. When I simplify my 3 radical 80, I can break it apart into a variety of ways. I chose 8 and 10. I broke apart my 8 into 2 and 4, and then I broke apart my 4 into 2 and 2, and I broke apart my 10 into 2 and 5. I put all my primes under my radical. I did my double on the inside, single on the outside, and I got 12 radical 5. So what I'm going to do, I'm going to basically circle my side work to separate it, because it just makes it easier for me. And now what I want to do is I want to do 24 radical 5 minus 12 radical 5. So 24 radical 5 minus 12 radical 5. And again, we keep our radicals the same, but we just combine the numbers on the outside. So 24 minus 12 is 12. So I have 12 radical 5. Try to do the next example totally by yourself. So when you do your simplification, you should be getting 7 radical 162 is equivalent to 63 radical 2. And you should get 3 radical 18 is equivalent to 9 radical 2. I wanted to subtract them. So I'm going to do 63 radical 2 minus 9 radical 2. So I have 63 radical 2 minus 9 radical 2. And I simply just do 63 minus 9, which is 54. So I get 54 radical 2 as my final answer. So there was your lesson today on simplifying expressions containing radicals and adding and subtracting radical expressions. If you have any questions, please don't hesitate to email me or Miss Daniel. You have our emails. And don't forget to complete your Delta Math assignment on simplifying radicals by themselves and adding and subtracting them. Tomorrow, for our asynchronous class, since I will not be seeing you on Zoom tomorrow, which is Wednesday, you'll be doing an edpuzzle. Have a great day, ladies.